Good morning, everyone. So what I want to talk about today is the gazebo simulator, and I want to get started with sort of the simple end of the story. So if we go ahead and look at the start script that I provide in the Homework 5 starter code for Gazebo, the first thing that we're doing is we are sourcing this setup script that got installed by Gazebo. If you go ahead and take a quick look at that, we can see that this is setting a bunch of environment variables to some defaults provided by the gazebo installation. So let's go ahead and source that script in our shell here. So now we have the sort of default gazebo configuration. And once we've done that, we can go ahead and run the gazebo program. I'm going to run it with the verbose flag just so that we get any extra output. And so if we start up just a default gazebo with no specific world, what we get is this. We have an empty world, and in the world, we can see there's some little bit of grid lines around the origin. We have our 3-dimension indicators. And then over here on the side, this can be a little bit hard to see, but we end up with two things in the default world that it provides. We get a light called the sun. Not sure exactly where that is. Oh, there it is. It's up in the sky above the ground plane. And in addition to that light, we also have the other thing. Yeah. So we have the light, and then below the light we have this plane, this big gray plane called the ground plane. And that's all we get. So one way to create a gazebo world is to go ahead and start gazebo, edit a world, and then save it. So I'm going to go ahead over to my Scratch directory. I'm going to go into 5335. We're going to create a V11 hidden folder, or a V11 folder, and we're going to create an example. Default.world is just going to be the default gazebo world file that we get when we start up gazebo. Now the world files that gazebo provides are XML files. We've looked at them already. Let's go ahead and take a look at that empty world file that gazebo gave us. So Scratch, cs5335, video for week 11, and we have this default.world. I can open it up in Vim. And we actually get a surprising amount of stuff, because when we save a world file from Gazebo, it creates one XML file with basically as much stuff as it can inlined. And this is a good reason to not actually create the world files that we're going to be working with this way. It's just like the old story with typing HTML by hand versus like using an editor that gives us a GUI HTML interface. If we want to just create an HTML file and we don't care about any maintainability, then using the GUI is probably fine. But if we want to be able to later edit the file and like understand what's going on by looking at it, it's better to type our own HTML file. Since the SDF format that Gazebo uses for all of its assets is also an XML format, it's useful to go ahead and type our own XML stuff. But we have two things in here. We have this light, which is called the sun. It's a directional light with some properties. And then we have a model called ground plane, which has some properties. Then we have some other stuff. I didn't even know this was stuff that we got by default. Gravity is set to Earth normal. And then, let me see if I can scroll down a little bit more. Get a magnetic field. We specify that we have some physics settings. There's audio support in Gazebo, apparently. I didn't know. This is on the Earth at latitude and longitude, so Gazebo is able to simulate GPS. That's something I also didn't know. And then we have some other stuff. And then hidden here, actually, I can go ahead and pull this off to the side just so that we can get the rest of this file. we end up with some rules about simulation, or some information about simulation time that was saved off. So when we save the world, it's going to save simulation time. It's going to save variable properties of the ground plane, so conceptually the ground plane could have moved. And then it's showing the state of the GUI where the camera was. So when we save off a world from Gazebo, it's going to save all of this information. If we compare that to what we had given as a default world file for homework 5, oh, this is a bunch of junk in it. But there's a lot of information that isn't in this world file. So we have this sun model in the world file that was provided for homework 5, where it's just a reference to an external model, the sun. The ground plane can just be a reference to an external model. Then this stuff was all sort of irrelevant, but in any case, we can produce a minimum world file that has the same content as the one that we get through the GUI without having to have all the complexity that the GUI provides. But that doesn't mean that it's not useful to work with the GUI occasionally. So type the right thing. There we go. All right. The other thing that we can do with this GUI is we can go ahead and insert more models. We just go ahead and click the Insert tab over here. It gives us access to, well, it gives us access to the models that have been used previously on this machine, but we also have access to this models.gazebosim.org model repository, where if we go ahead and get some arbitrary thing like an orange jersey barrier and plonk it into our world, if that's locally available on the computer, it'll just go ahead and use that. And if it's not, then it will download it. The first Robotics 2016 has a moat. I'm not sure why that's called a moat, but fine. Portcullis? Yes, clearly we need a portcullis in our world. There's some things in here that are relatively complicated, like we can take a complete Polaris Ranger UGV that's like relatively accurately modeled and just go ahead and plonk this down as the basis of a like self-driving car simulation or self-driving golf cart simulation. There's also a Toyota Prius in here. We can get a Toyota Prius, and this has sort of a full set of self-driving LiDAR sensors. So this is kind of like the self-driving car that Google was using for their early self-driving car testing. So some of these models come with sort of complete robot stuff. Now that we have this self-driving car, I actually want to go ahead and list gztopic-L, and we can see that, okay, so the Polaris Ranger is a functional robot with a bunch of stuff. We can do, we've got a brake pedal. Yeah, I don't know if this has complete control. We have things like the gas pedal, but I don't think that actually like drives it forward. I don't know, it might. With the Toyota Prius, it has a GPS, it has an IMU, it has multiple cameras, it has multiple LiDAR sensors, apparently it has sonars, it has rear cameras. So this might be a really interesting model to look at in some more detail if you wanted to figure out how to build a complicated robot. And that's basically all we've got in here. But if we go ahead and save this one off, we can see that we have a somewhat more complicated example. Scratch 5335 v11. So if we go ahead and look at that, we can see that we still have the sun and the ground plane, but now we also got these models like the Polaris Ranger. Okay, it looks like we don't have any control plugins or any control plugin on the Ranger. We've got some sensors. Let's see if we end up with any. Oh, we do have some cases where geometry meshes are still being included by reference, which makes sense. I want to see if we can find plugins. Plugin. Okay, so that doesn't look like it gave us any sort of non-standard plugins. Some of the links here with the Prius somehow are producing topics. And clearly we have LiDAR. So let's see if we can do laser here. Here we go. So the sensors are not actually being provided in the model block for the Prius. They're just here separately. Here's the camera sensor we get, etc. So we can explore effectively by using the GUI, and then modifying things. But this probably isn't the best way to actually produce the worlds or the models that we're going to be using for our work. This is just a big old XML file with a bunch of like sort of arbitrary constants in it that we didn't write, so we don't necessarily know what it means, and therefore we don't necessarily want to personally maintain it. So the alternative to that is writing our own world files from scratch. So I'm going to start off by making it so that I have two terminal windows here. So here's a world. And then what I want to do is write my own world file. So this necessarily starts off XML version 1.0. And XML doesn't have a closing tag because that's not a real opening tag. But we do have SDF. And it looks like the current version that we're using is 1.6. Now this may change the meaning slightly of some stuff. We'd have to go look at the SDF standard to see what the differences are. But I think we can get away with just going ahead and including our sun. We can go ahead and include our ground plane. And then I want that Polaris Ranger EV. So to do that, I'm going to go ahead and run I don't remember. Yeah, this is the terminal that I used for Gazebo. So if I run Gazebo in it again, I can actually see that, but Gazebo will pop up. And then to actually find out what the name of things are, go ahead and look at the models list here. I don't want the Prius. It has too many lasers. I want that Polaris Ranger. Let's see, much nicer. Now if I go ahead and look here, we can see that this is called Polaris Ranger EV. So I bet if we say include model Polaris Ranger EV, we can now go ahead and I'm on the wrong side. Let me put me on the other side so you can see me typing. I can go back over to Scratch, 5335, V11. I can verify that this is my gazebo terminal. Then I can say gazebo verbose custom world.world. I get that crash. I'm still not sure what causes that, but we end up with this world that has literally nothing in it. So this is a completely empty world for some reason. So I'm missing something that was in the sample world before. Let's see if we can figure out what I got wrong. World. Haha. World name is example. Alright, I'm bored of that. We're going to go ahead over to Emacs and properly indent this. Part of the problem that I need a second question mark here, yeah. Getting my XML syntax wrong? Okay, now this can indent. I'll just indent it manually. Fine. Looks like Emacs can't figure out what's going on with sort of generic XML. With the NXML mode, it's insisting that we have something complicated going on. So, in any case, we can now gazebo that world, and we get to find out if that solved the problem. There we go. Now we have a world with our sun, our ground plane, and our Polaris Ranger all together. So that is the basis of how we can figure out how to put things in the world and how we put them there. The next thing that we can do is move objects. So we have one object here. I want it not to be at the origin. In fact, I'm going to put in another one that's not at the origin to demonstrate that we can have two of them. So we're going to go ahead and include another Polaris Ranger EV. This Polaris Ranger EV is going to have a pose. And rather than trying to copy the pose from an existing thing, I'm going to go ahead and pull up the SDF standard so that we can see how to do this properly. So let me go ahead and make the Firefox window. Pull up the SDF specification. And so over at sdformat.org, this is where this is actually documented. So what we're looking for is, if we have an include, how do we do a pose? We're working with SDF16. So a world has some properties, including these includes. Then within an include, we can have a pose. And the position is XYZ, roll, pitch, yaw. So X, Y. I'm sure that X is a horizontal coordinate, so roll, pitch, yaw. So that should be 10 over in the X direction. And then if we go ahead and run gazebo here, eventually we will get only one Polaris Ranger because we have an error with Polaris Ranger already existing. So back at the SDF specification, if we do an include, we can change the name. I'll just call it Ranger 2. Then we will try spawning it again. So now we have 2 Polaris Rangers, 1 offset by 10 in the X direction. So that's the sort of absolute basics of a world file. And figuring out how to do more than that is a question of looking at the examples, both the examples that I've provided and the examples that are provided with Gazebo, and looking at this SDF format specification. I understand that documentation can be annoying, but there's some nice clear examples here. The specification is relatively clear, so you should be able to take advantage of that, that documentation. All right, I'll be back in another video with the thing that I'm covering next.